All right, seeing none, I'm expecting awesome posters on your first draft. We'll turn those around as quickly as we can. I'll try to get mine back to you within 24 hours. So you'll have the weekend to finish them up. But don't wait on us to begin working on your presentations. You should be working together as a team to figure out what your 3 to 5 minutes is going to look like. Teams 1 through 5, I'm just going to go ahead and say teams 1 through 6 are going to present on Tuesday. So let's front load the presentations. That way we'll only have teams 7, 8, and 9 left for Thursday. I'm going to ask on Thursday that, particularly if you've already presented, I'd like to have as many people in the class as possible on Thursday. So I realize that if you have symptoms and all that stuff, you shouldn't be coming to class. But Thursday, I would like for people to come here because I've got our interim department head, Dr. Tsz-Yi, is going to come here, and after the last 3 presentations, he's going to lead a discussion about the curriculum, and he's going to solicit your input. What's going on in the department is, our previous department head retired, and before the dean allows us to look for a new department head, he wants the department to have a strategic direction. So he's commissioned Dr. John Tracy, who's the director of the Texas Water Development, Texas Water Resources Institute, and also an adjunct faculty at Texas A&M, to be our interim department head to lead that effort. He's a great guy. I've enjoyed getting to know him. He has a lot of experience in water resource management, particularly in the Midwest and in the American Northwest. But I'm counting on y'all to help him understand what ag systems management is all about. We've been telling him, but he needs the student perspective. So Thursday is the day for that. He's going to be in here. He's going to ask you questions about the survey with regard to what did you like best about the curriculum, what did the classes that you take, what did you like the least about it, what do you expect to do with your ag systems management degree. He really needs a vision on why you are majoring in ag systems management. And number one, is it helping you to achieve what you wanted to achieve in terms of your employment pursuits, or what can we do better in terms of modifying the degree or improving it to make it more useful. So that'll be a really important time that y'all have an opportunity to shape the near term and the distant future of our department, particularly with regard to ag systems management. So that's something we do every year in the last class in the spring, is we try to get the department head in with the seniors to talk to them about, to get their perspective. You have the most recent experience on what 4 or 5, a few more years looks like in the ag systems management curriculum, so your input is important. This is why it's important that supervisors, administrators, people who are involved with the work that's going on in an operation, like you might be someday, that you're intimately familiar with the impact of administrative decisions on your operation. Some administrator somewhere decided, hey, let's have a test of the fire alarm, without realizing it's a test. What are they trying to accomplish? They weren't trying to accomplish evacuating the building. They were probably just seeing if the sound worked, if all the lights worked. I don't know. Could they have done that perhaps on a Saturday, Sunday, when there wasn't, not going to interrupt the operations going on? Anyway, just remember that someday when you're in charge of something, think about the impact of any training you might be doing. Okay, so before I was interrupted, I was talking about I'm asking you to come to class next Thursday to interact with our department head. Any questions about that? We typically have the Ag Systems Senior Survey. We're going to try to do that on Qualtrics. You got that? Is that going to work out, you think? Okay. We're going to post that on Tuesday, or we'll talk about the timeline after class on that. Okay. All right. So on top of your end of course critique that you need to do, you'll also need to do your Ag Systems Senior Survey. The end of course critique is a university APHIS website that you're going to go to, but the Ag System Senior Survey is kind of an in-house survey that we use to improve the major. All right. Well, with that, let's press on to our class today. All right, so I'm going to review, do a hot wash of your written reports and your presentations. So the overview, what we're going to talk about today is the project content. A lot of what I'm going to talk about is each step in the project, and it applies to both your written reports and your oral presentations. So what I'm going to say on that is about the content of the way you develop your background section, your potential solutions, economic analysis, all that stuff. So whatever you did there, good or bad, translated into both your written report and your oral presentation. And then I'll talk about the oral presentations themselves, about the style and all that. And then I'll get into specific critique of the written reports. So I'm sure you're all excited to hear this. I'll try to make it as brief and as useful as possible. Why are we doing this? Well, there's not this is kind of part of the whole communications intensive part of the class. Is we're supposed to give you feedback. We've given you written feedback. We've given you oral feedback on your presentations. This is one last attempt. This is probably the last feedback that you're going to get on your project and what you've done. So it's an attempt to just close the loop and make sure there's common understanding on what was expected and what hit the mark and what didn't. All right, so first of all, on the background, I'm going to skip over the project description. That doesn't mean it's not important. That simply means that most of you did good. Unfortunately, most of my comments are going to be more critical in nature in terms of what we were supposed to do and what you could have done better. But your project description is really the most important part of the reporting process. That's where you actually identify the problem and start to put boundaries around it to define the scope of the problem. So project description was the first thing that you did, and for the most part, you got that right. So let's move on to the background of the project. The literature review is one area that I want to highlight. Make sure that when you do your literature review, and you're thinking, well, I'm never going to do one of these again. Well, you may not do one specifically like this, but this is a template that you can use, and you still can use some of the other principles if you're having to write some kind of report or do some sort of problem-solving process in the future. So make sure as you're reviewing the literature, when you're out there looking at sources, you've got to go beyond Google. Okay, Google is actually pretty limited. It's not going to get you the quality sources you need. And at the beginning of the semester, we talked about using the university library research system and other things like that in order to get you to past all the static and the noise that you'll find on the internet to actual authoritative sources, such as peer-reviewed journals, people who have written from a scholarly or academic point of view toward a problem and done some analysis on it. You want to make sure that so first of all, your literature review, you need to try to prioritize authoritative sources. Find sources that are actually going to speak with authority instead of just a company's website. Remember, they're trying to sell you something. So what they're going to present is probably not the most objective statement of a problem. Your sources need to be relevant to your problem. There's lots of sources out there, so you need to kind of focus in on the ones that are going to be the most relevant to your problem. And then also good sources in your literature review are going to be those that help you to collect data. Data with regard to, some of you had a water aspect of your problem, so rainfall data. So you want to get a good authoritative source of rainfall data. So here's an example of one source, and this is a source of information about solar irrigation. And it was retrieved from a website, solarpumps.com. Compared to another source, really in the same paper, I believe, this looks like a peer-reviewed journal because it's from the Food and Agricultural Organization of the United Nations. Maybe not the greatest source, but it's still it looks more, it's more scholarly and probably has more objective or reviewed information than the one from the from the website. Okay, so I'm showing you maybe an example of one that's not so authoritative compared to one that is. Okay, back to the background. Similar solutions. When in the part of the paper where you're looking at similar solutions, I feel like this is a really important aspect of the problem-solving process. Try to find other people out there who've experienced a problem similar to the one you're working on, so that you're not reinventing the wheel. It's really hard to come up with a brand new solution to a brand new problem right off the bat. So most problems are not brand new. People have experienced them before. So inform yourself onto what other industry solutions might look like, or problems might look like, and then what their solutions will be. Expand your scope. Don't just confine your search to the state of Texas. You know, and that's why having global experience is so important. That you see different areas of the world, and where you know, a lot of places I've been, I look at it and I go, you know, that's a lot like Texas. Or you know, Texas has a wide geographic variety. So we've got the coastal bend, where it's kind of a maritime, humid climate, up to the high plains, where it's arid desert, and of course South Texas, West Texas has its own climate as well. So expand the scope of your research when you're looking at agencies or industries that might have a problem similar to yours. Let's see. So here was one that I pulled out. Here's somebody that I just copied this out of the paper. Here they looked at, they expanded the scope beyond Texas, beyond the United States, and they looked at Greece, where it's a climate there where they've got limitations on rainfall and water. And so they developed different ways to cultivate crops, and different crops that would be suitable for that situation. So I think this was the team from Aguilares. They determined that, or the team that was working on the problem in South Texas and Aguilares, coming up with the cropping systems for the challenges in that area. So they were looking at other places. So that's a good place to start. Moving on to standard and regulations. This was an area that had a lot of problems. What we want you to do here is pick 3 or 4 regulations and discuss the standards and regulations, and then cite where it came from. Don't just say there's a lot of OSHA requirements we have to meet. There's a lot of water quality requirements we have to meet from the Tsz-Yi. Yeah, that's not really helping the client out. So pick 3 or 4 specific regulations, state what they are, summarize what they are, and give the citation on where you can find more information, and then present the impact on your problem or your solution. Okay. So here was one that was pretty good. I think this was a problem that was looking at having either there were generators already in the industry or in the problem, or their solution was going to call for a diesel generator. So here they talked about that the Tsz-Yi has some regulations for generators. Didn't get into specific what it was. I think they're talking about emissions from those generators, but that was kind of a going in the right direction. Moving on to flow analysis. You've heard me say this a lot. A lot of teams struggle with this. You know, what is flowing through your system? And so you really have to take a look at the system as it is and see what is flowing through it, whether it's electricity, whether it's some kind of material, whether it's water, maybe it's air, maybe it's some other aspect of it. There can be a long list, and there should be. Make an exhaustive list, and then pick the top 3 or 4 that are going to be the most crucial in the development of your solution. Which 3 or 4 things in your list that are flowing through this problem, this project, that need more analysis, and that's where you do the detailed quantitative analysis. Quantitative meaning use numbers. And a lot of you saw our comments, you know, Q versus Q, QBQ. a lot of your analysis was qualitative and not quantitative. So you said there was a lot of rainfall. There was not much rainfall. Those are qualitative terms. You need to use quantitative terms. This is where you're supposed to do the actual analysis to, in most cases, determine what the status quo is. What is in my system now? And here are some things. Water, how much water is flowing through my system, whether it's rainfall or supplied by a well. Maybe it's utilities, how much electricity is available. What is the source of electricity? Nutrients, if you're doing some sort of a soil or cropping system, what nutrients are available in the soil. And then you can compare them in your flow analysis to what might be required. Or at least in your flow analysis, establish what the status quo is. So as you develop your potential solutions, and your solution may have a greater requirement for water, or a higher requirement for utilities or soil nutrients, you'll be able to establish what the difference is. And your solution is going to have to bridge that gap. So, your flow analysis, three to four things that flow through your system now, and do a quantitative analysis on that. A lot of you did that, but a lot of you missed the target on that. And then your potential solutions need to be three independent standalone solutions capable of solving the problem. So your potential solutions are going to be derived from your flow analysis. Once you determine what the delta is, in terms of what is needed for my solution, you're going to craft three different solutions that are very different. Each one of them, the client can pick and say, yeah, that's the one I want. Some of you just developed one potential solution. One was just kind of one component, maybe an irrigation system. Potential solution two was we compared different energy sources, and we determined the diesel generator was the best one. Well, that doesn't talk about irrigation or other components of your system. So you have to, each potential solution has to be standalone. It's got to have all the components there, and it might be capable of solving the problem. This was a good description of a potential solution, I think. No, that was a flow analysis. Okay, so this flow analysis here was from one of the cotton problems. But there's several numbers in there. You got talking about modules flowing into the module feeder using hydraulic power, and then average feed rate roughly 8 to 12 units per hour, or every one module or unit every 5 to 7 minutes. So they did some analysis in the process of their flow analysis. This is another one. This was the air quality problem in the grain elevator. So here they took a look at the grain elevator, annual throughput of 2 million bushels. They focused that down to 10,000 bushels a day. And then they took a look at what the emission rate in terms of pounds per hour from the dust would be, and they determined that the factor for the hopper truck is 0.035 pounds per ton. That was actually part of the flow analysis. So they kind of took some literature, and then 1,000 bushel a day estimate from our client. They determined what their problem was. They were able to use the flow analysis to determine what the scope of the problem was, and that was a emission rate of 0.032 pounds per hour. Okay, moving on to the recommended solution. Recommended solution is going to be more detailed than the potential solutions. Here, you can flesh this one out once you've chosen it and recommended it to your client. Some potential aspects of the recommended solution would be describing the components of the solution, perhaps with a diagram or a schematic. The labor required that's going to operate this recommended solution. Some training that might go into that before they're able to do that. And then what it's going to require. It's going to require more additional water, electricity, and where's that going to come from? Economic analysis. There's really three basic components to the economic analysis. One is, what is my initial cost? What's it going to cost the client? This is what we call the initial investment. And so that would be a table where you add up all the components, all the labor, the installation cost and everything, even the training, the initial training, And this will be upfront costs the client's got to come up with and pay out, either in terms of cash or you've got to get a loan, to buy and install this solution. The second component of the economic analysis is the operating costs, typically done on an annual basis. So this would be another table that would describe, quantify the annual operating costs. So each of those tables can finally be represented by one number. You've got your initial investment cost, then you've got my annual operating costs, and then I can use that annual operating costs to do a time series cash flow, either 5 years, 10 years, or whatever is appropriate. So the third component then of the economic analysis is the actual analysis of those two aspects: the initial investment, the annual operating cost. Now, the annual operating costs, you're going to need the revenue that's generated from that too. That's what I've tried to demonstrate here. This is a modified version of somebody else's report here. So what I've got, let's see if I can use my pen. And on this table, and I'm going to ask for some class participation here. So I've got the, so this would be perhaps a third table. I've got another table out there that quantifies the initial investment, and that would be this. The initial investment, the bottom line of that table, after I added everything up, was $7,000. That's the initial investment of the client, and so that's going to be a net $7,000 minus $7,000. Then I've got the annual operating costs. Annual operating costs, I've got some more information. Maybe this is 5 years, so I've got a 5-period time series where this should be expense. So the cost is $700 or $600 every year to operate it. I suppose that's some labor costs and some maintenance and other things. But look at the revenue generated by that, and so that gives a profit. You know, 3,000 minus 600 gives me $2,400 profit. So using that, I can begin taking 2,400 and adding it to the minus 7,000. And so the first year, I'm only after the first year of operating, I've recouped some of that initial investment. So now I'm only in the whole 4,600. After a second year of making 2,400, now I'm only in the whole 2,200. But look here, during the third year, I finally see a positive cash flow. And so this is how you do your cash flow analysis. And then you could follow up with the payback period. That's going to be somewhere in the third year. You're going to be break even. And then you can follow on with the net present value analysis and your rate of return or return on investment. So you need to include the revenue in this, and you need to cite the justification. How do we imagine we're going to make all this money? So you just can't come up with, we think it's going to make this much. You have to provide some justification. Some teams did that really well. So economic analysis, this is one of the, I would say, one of the fundamental things that our ag system students can do that that our your engineering counterparts do not have as much education in or classes in. Okay, so this is something that you're fuzzy on. This is something you really want to have a good handle on before you get out of it. And this class is probably your last attempt to do that. Okay, risk analysis. Again, there could be a lot of risks associated with the project. Risks, uncertainty, there's learnable risks, there's random risks and all that stuff. The bottom line is, yeah, you can mention all those, but pick the big 3 or 4 risks, the most risky, the riskiest risks, and do your analysis on that. So what we're looking for is you identify that risk, and each risk should be followed by what? Everybody say it together. Starts with an M, rhymes with litigation.
Mitigation.
Mitigation, thank you very much. So you follow each risk with some sort of mitigation step, something that's going to reduce the impact of the risk. And what this means is we've come up with a solution to the problem. It's going to solve the problem, but it's also, there's going to be some associated risks with implementing this solution. And so you want to be upfront with your client and let them know that, but you you don't want to just scare them off and say, well, these are all too risky, I'm not going to do that. You do the further analysis to explain to the client what he needs to do, what you're recommending he do to mitigate each one of these risks. Okay. Implementation plan. Probably the biggest, most of you did this pretty well. I saw some Gantt charts, I saw some network diagrams that are on there, project network. Probably the biggest critique here is the implementation plan needs to be more than just the installation of the solution. The installation is simply one part of a larger implementation plan. So the implementation plan, could last several months or perhaps a year. You'd look over a year of how this system's going to operate. I've seen some implementation plans that go out over several years. But it focuses on the implementation of your recommended solution. So it's not just the installation or the construction of this thing, of your solution. That's going to be a part of it, but it's not the entire implementation plan. Gantt chart, a lot of you got Gantt charts, so those worked out pretty well. Those are challenging, I know, particularly the longer the timeline you're going to have. The numbers get pretty small in there, so you snap to do the best you can. Project network, I've got an example of one here that's pretty good. So your project network kind of lays out the activities of your project in a way that the client can understand. Some of you did a good job of explaining the activities, and you called that, step 1, step 2, step 3. And in your project network, the boxes just have 1, 2, and 3, and so the client is like, well, what's 1, 2, and 3? I like this one because it's got the name of the activity or the step, so it's a lot more easy to understand. And it's got the time involved with each one of these activities. There's two things missing, though, from this project network. Who can tell me what they are? Who can tell me one?
Critical path.
The critical path. The critical path is not very easy to see here, okay? Since I know something about critical path analysis, I can probably figure that out. Now, does anybody remember what the definition of the critical path is? The longest path through the network. So here I've got 2, 8, and 2, that's 12. This is 7, 2, and 7, that's 16, 17, 18, that's 19. Oh, but I've got 4 here, so this 12 plus 4 is going to be 16. This is going to be 23 in the middle path, and this one is just 3, 7. So the critical path is going to be this one. So some way, maybe making the arrows darker, like I did in class, to demonstrate what is the critical path. We clean that up. What's the second thing that's missing off of this graphic?
Is it the total days?
Yeah, the critical path time itself. I had to figure that out, and you saw how messy my math was here. But the 23 takes 23 days to complete this project. So it's really easy just to go ahead and throw that up there on the graphic to make it complete. Okay. But hey, I'm not taking anything away from the team that did that. It's a nice job. Okay, so that's enough of the content. Now let's talk about your oral presentations. Really impressed with the effort that you put into this. We required that you actually had to review the video of your first oral presentation and do a self-critique. I didn't get a chance to ask each of you what you learned from your self-critique, but it was apparent that you took it seriously because generally we saw people getting better each time. Let's talk about your voice quality, and I think this may be a function of those of you who presented on Zoom. It's hard to imagine yourself in a room just sitting in your bedroom or maybe a study cubicle and just you and a laptop, and maybe there are other people around, so you're not one to talk very loud. I get that. Just keep in mind when you're making a presentation, your voice needs to be firm. Okay, you need to exude some confidence in your voice, and the downfall of making a computer-based or online presentation is that you're only talking to the computer. And so you're going to be talking in a softer voice, maybe not very persuasive or forceful. So you have to put yourself in the room when you're doing a Zoom presentation. So I'll be looking for that when you do your poster presentations next week and also on your final presentation. So make sure that your voice quality is able to transition from just your conversational, quiet voice to more of a firm presentation voice, okay? Your timing. Also, I noticed the people who were presenting on Zoom tended to go a little more quickly. And I think that's just a function of you're not mentally putting yourself in the room. So if you notice during my presentation, sometimes I'll pause just to allow you to process what I just said. Those pauses are not random. I actually do that to help you to let everybody take a break and process what I just said, so I just don't ramble right through the whole thing. So don't rush your presentation. Also, you need to speak clearly, particularly if you're doing a Zoom presentation, because the microphone is going to cause problems. So there's actually, when I was in the Marines in a squadron with lots of other pilots, there was one guy, of course, we all have to talk on the radios when we're flying. So we're flying, we're in the aircraft, there's a lot of noise, we're wearing a helmet, we've got a headset, and we're wearing an ear set. So inside my helmet, so I can hear what's going on in the radios. And radios are very cluttered, a lot of people talking, and it's hard to understand people sometimes. But there was one guy who was really good at talking on the radio. His call sign was DJ. You know why his call sign was DJ? He used to be a radio disc jockey before he got in the Marines. He made a living talking on the radio, and he learned and taught us how to talk differently when you're talking on the radio. So you make your consonants more crisp, and you try to have a little bit of a pause between each word. You don't just ramble on like this, like we're having a conversation, because your words tend to run together. So when you're talking on the radio, when you're giving a presentation, particularly when you're giving an online presentation, you want to have your words to be clearly articulated and crisp, so it eases the understanding on the part of the listener. Also, don't just read the slide. There were occasionally where students would either be reading the slide or you'd be reading your notes that you had. That's pretty easy to pick up on. By the time you give your presentation, you should be familiar enough with the material, knowing the material enough to be able to look at the bullets on your slide and talk for about 30 to 60 seconds about that without having to read it. Now, it's okay to have some notes to keep you going, but generally what's on the slide should be enough of a guide to remind you what you were going to say. And if it's not, then you need to rehearse it a few times. Okay? So this kind of goes back to the importance of actually knowing the project, being involved in the project, knowing the material well enough to be confident in your presentation that you're going to be talking about. One thing I really noticed was that I didn't see a lot of stage fright or nervousness. If you were nervous at the beginning of the semester, I couldn't tell it. And then with practice, you get less nervous anyway. So good job there. I was really happy with the oral communication. I feel like that part of the class was really, that learning objective was met very well. Okay, on to the written reports. So the style of the written report we're going to talk about, first of all, ASAB format. I was a little disappointed in that there was some backsliding from last semester. We worked really hard to get y'all into how to do the citations and references, the tables and figures, and all that other stuff. So I just want to remind you, particularly as you're putting together your final report, and also in the future, to pay attention to the proper way to cite a source, and then to list the source in the reference. The overall paradigm that you're trying to follow is the citations are breadcrumbs that will lead the reader to the source of that information, which will be more apparent in the reference. That's why the author's names are listed first in the references, and when you have the citation, Smith, 2007, That's going to cause me to look at the references, which are in alphabetical order, by the way, and I'm going to look in the S's to find Smith and whatever Smith's name is, and Smith et al., or Smith and whoever else wrote it, and the year it was written. Then I know the reference, and I can go look up more information if I need to. If it's a website, okay, you're probably not referencing a website. What you're referencing is the company that owns that website. So let's say you're referencing John Deere's website. Your citation shouldn't say johndeere.com. It should say John Deere, comma, 2018, or whatever the source of that, the year of that information is. And then down in the references, it'll start with John Deere, 2018, maybe the name of the article, and then finally the tag of the website at the end of that. So try to make it easy for the reader to find the source of the material that you're citing in the paper. Also, your references, you may have more references than you actually put in your paper. You're going to call some references. I mean, you did a lot more research than you actually used. So don't throw every reference that you found in the reference section of your paper. This is not a bibliography. You only put a reference in there if you cite that reference. If you don't cite the reference, we really don't want to see that in the reference section. Tables and figures, just review what is a table where the caption goes, what is a figure where the figure goes. People got that most. The most common error here was you would have a table and you wouldn't mention it in the text. So what we're expecting to see is, table 7. So in your text, you're talking about the economic analysis. The initial investments in this project are shown in table 7. And then you go ahead and talk about it in the text. And below that paragraph, I'm going to see table 7, and it's going to be labeled initial investments or something like that. So make sure you mention the table or figure in the text before the figure appears. Numbers and units. I had several people beginning sentences with a number. There's a general rule about when you begin a sentence with a number. Who can tell me what that rule is?
Comma afterwards?
That's a good try.
Spell it out.
Spell out the number. You don't actually use the numeral. So if you're talking about, a nine bladed fan, you're going to spell out the word 9 if it's going to be the first word in the sentence. So that was one of the most common errors. And then units, try to abbreviate units using a standard abbreviation, and then be consistent with that abbreviation throughout the paper. Not a big deal. Only the thing I'd like to see the most improvement on is the organization of your papers, using headings and subheadings. And a good example is my PowerPoint slide. Notice how I've got a heading up there that says style, and then I have a subheading, ASAP format, and under there I've got 4 other bullets. Okay. Well, this could be the outline of perhaps your risk analysis. Okay. So the first line might say risks, and the second heading would be learnable risks, and then you would have your first risk would be insufficient rainfall. Would be your third subheading, and then you'd have a paragraph that talked about the risk of insufficient rainfall and how you're going to mitigate that. So I'd like to see more use of these of the headings and subheadings in your paper. Okay, lastly, in writing, just remember business writing style. University Writing Center is your friend. I don't think as many people use this resource as you perhaps needed to. It's going to be probably tougher at the end of the semester to get on their calendar, but it might be a good idea. I mean, there's 700 points on the line with your final report. That's a big chunk, so maybe good to go ahead and think about getting the University Writing Center's help, particularly if you struggle in this in the beginning. In business writing, try not to, a lot of you were writing in first person. My team did this and my team did that. Well, you're writing as a team, so you should say our team. Don't use your client's names. They know what they are. Just refer to the client in the third person. The client listed the following constraints. So you don't have to keep repeating their names or their company or anything like that. Avoid colloquialisms. I think that in your paper is pretty hard if you have colloquialisms. Things that are not formal enough really to qualify as business writing. We talked about that last semester. I'm not going to go over that again. Just the University Writing Center can help you avoid colloquialism. And then drawing tools. I want to have a discussion about drawing tools. This is something that I think we're struggling with in our Ag Systems curriculum. I'm not seeing a good connection between what you're learning in MMET 105 and what's coming out on the paper. I've got an example here of some drawings, which are kind of the expectations that we had, but these drawings were actually provided in this particular paper, were I think provided by the client. So the client's got some drawing tools, but I need for my students to have some drawing tools and some drawing skills. So y'all come up on the net here and talk to me for just a minute about what were some struggles. What is the block, the roadblock here between what you learn in MMET 105 and getting that drawing type skill into your paper? Somebody tell me what we're missing.
Well, in MME 105, that's a very intro level class. They actually only do 2D modeling, and that's actually not even an AutoCAD drawing. That's a 3D civil drawing. So that we would have to take like 3 or 4 design classes to get to that level.
Tristan, I would actually like to clarify. I think it's changed now. I took MMET 105, I don't know, maybe 2 semesters ago, and it was the first semester that they had introduced Fusion 360, which is a 3D modeling program. However, I do agree that it is incredibly introductory, and I'd like to make I'm not going to say a point, but think that it might be 3D modeling, especially in more complex form, might be a stretch for, I would say, non-engineering majors. In terms of that class, gave us more of an understanding how to read drawings 2D and 3D alike, but not so much in terms of physically creating it ourselves, for lack of a better term.
Yeah, I would agree with that when I took it.
And also with Fusion, it does relatively well with 3D modeling, but especially for a technical report where they're going to have to manufacture a part, it's the technical drawing, like software that it comes with, leaves a lot to be desired. I mean, it can't hold a candle to something like AutoCAD or other, like the standard 2D technical drawing packages that are out there.
I think also, like, I tried using it again after that class and I couldn't get the license back and stuff. So I don't know. We should still have access if we go to the office and stuff, but I don't know how easy it will be to gain it back.
Okay, this is good feedback. It's important to us on the curriculum committee. We've actually, mentioned this as a stated desire. Is we want our Ag Systems Management students or graduates to have some sort of drawing capability, because while you don't have an engineering degree, you still are going to have you need the capability to draw out something, perhaps that you want the engineer to further design, and you just can't do that using a pencil and paper. So we want to bridge that gap between pencil and paper and Fusion 360. So we're working on that. It sounds like maybe, Kyle, since you've taken the class recently, we're kind of getting a step in that direction. Would you say that may be the case?
Yes, sir, for sure. And Professor Whiteacre, when it did come out, said that, or for our semester being the first one to do Fusion 360, that MMET students normally don't get introduced to Fusion 360 until their, I think he said junior year. It's normally a higher level class in their curriculum. So I think that being paired, a more complex program being paired with virtually no prior experience, leaves a student familiar, but I wouldn't say comfortable to really tackle and fully execute a detailed drawing in 3-dimension.
Okay, that's good feedback. So our curriculum committee has some work to do. We either need to reset our expectations, or we need to find a solution with the one MMET class that you're getting in order to meet that expectation, or we're going to have to add more drawing classes to the curriculum. So I appreciate that feedback. This is the kind of stuff that typically we would talk about on the senior survey, but since it was kind of so fresh in my mind, I really wanted to get some of y'all's honest feedback there. Okay. Well, that's all I have in terms of the hot wash. Again, I want to acknowledge that I have hit the areas that I felt like kind of fell short and needed improvement. But overall, I really want to salute you and the effort you put into these projects. These are difficult projects. They're not like you've had in your other classes where there's a textbook answer. Every one of these projects was open-ended. It was open-ended on purpose. You've got the difficulty of trying to contact your client. That's a good real-world experience. Hopefully, you were able to develop some skills on how to do that, at least with your client. Every client's probably going to be different. And maybe you're not a consultant or something like that working with a client. Well, these skills are still going to translate into let's say you're in building construction and you're working with subcontractors. You're actually the client and you're trying to work with them. So you're going to have to establish communication with people and communicate to them what you want, or vice versa. Maybe you're the sub and you're working for a general contractor. So there's lots of translatable skills from this very open-ended, sometimes uncomfortable team project, not the least of which is dealing with your classmates, other team members. One of the challenges of college team environment, whether you're on a 4-person team with a bunch of seniors, or you're a student over in the Corps of Cadets and you're trying to tell underclassmen what to do, you get to practice in college some of those team dynamics, some of those working together relationships that are really going to benefit you in the future. So you're able to kind of struggle with those things and learn what works, what doesn't work, and learn some techniques of how to get things done when it's hard to communicate with people. And most importantly, I hope you learn the benefit of being a good team member, about being available, being so when your team is trying to get something done, you're just not unresponsive. Coming up and being responsive quickly is an important part of getting the job done. Also, hopefully you learned how to be resourceful. None of these projects were covered directly in any of your classes. Nobody was taught how to find plastic in a cotton gin, or how to select crops in for a wind tunnel, for a high tunnel. Okay, but hopefully you were able to find tools from your curriculum to apply to those projects, because there's still going to be a learning curve. You still have to learn. So what is specific about this project that I can build upon from my knowledge? And that's really what a college education does for you. We're not training anybody for one particular industry. We're giving you foundational knowledge that you can build upon when you do get that job, that you'll be able to have some understanding of the fundamentals to make you be able to do your job effectively. That's the whole purpose of what we've done here in the capstone class, trying to integrate your curriculum, the classes that you've had, not just the Ag Systems classes, but the business or Ag Eco classes you may have had, and then to prepare you for the workforce. So this is kind of our launching off point. Now, next week, you're each going to have an opportunity to talk briefly in front of the class about your project. So, be prepared for that. This is your time to report to the class on what you did. There'll be time for questions and comments, not much of one. So so next week it should be pretty low key. It should be fun and not a lot of pressure. So look forward to next week and enjoy it. But particularly on Thursday, when you talk to Dr. Tracy, be prepared to talk about the good and the bad about our curriculum. Okay, does anybody have any questions for me?
It's one comment in the chat.
Okay, thank you, Jan. I've got one here. Also, MET isn't required for us. I think if it was made clear how to use it. Yeah, look, man, I've been on the curriculum committee for 10 years. MET 105 is required. I don't know how it could not be required. It used to be Engineering Design Graphics 105, but that department merged into MMET, and now it's MMET 105. So I'm not sure.
I think they changed it to where you can take that, or I think it was like ISTM, but there's an option that you don't have to take it.
Yeah, I'm the guy who has the keys to the curriculum. That they would have not done that with my approval. So I have to think you're wrong about that. But again, I'll go back and double check. Okay.
And Colonel McGee, I'm actually in MMET 105 right now, and I think he has kind of stepped up his game because we're in a pretty strenuous semester project that it does have 3D modeling in it. And it takes you 3 or 4 weeks to complete it. So I think he has stepped up his game, and he's a very good teacher. And I think he did put a pretty good strenuous project on us this semester.
Okay, thanks, Reed. I appreciate that. You know, I think there may not be that many majors who are taking the MMET class. So the fact that we met with him and told him what our requirements are for our students, obviously is having some impact. So, well, sorry it was such a struggle with y'all this semester, but your efforts will make it better for the next group of students to come through. All right, well, if there's no other questions, why don't we quit early, and we will see you. Remember, teams 1 through 6 are going to be ready to go on Tuesday, and teams 7, 8, and 9 on Thursday, followed by special time with Dr. Tracy. So y'all get your posters turned in and get your final report scheduled, and we'll see you then.